In section 2.4, we'll be solving quadratic and cubic inequalities. So let's first start by reading this little blurb up top because it's going to make the process in which we solve inequalities for quadratics and cubics a little different. It says, remember that when we're solving an inequality, you generally want to solve the related equation and then use a number line to test intervals. Just like remember when we did with our absolute value functions, we would have a function like this, and then let's say we were looking at a line like y equals 5. Sometimes we would be looking above that line for our inequalities, and sometimes we'd be looking below that line. So we would have to test our numbers on an interval to see what our inequality symbols were going to be in our final answer. So if we continue reading, it says, however, recall that when a related function is one-to-one, you can simply solve using inverse operations. So just like back in Algebra 1, if I gave you something like negative 2x plus 3 is greater than 7, you would just have to solve using inverse operations and possibly flipping this sign if we multiply or divide by a negative. And that's because a linear function is one-to-one. So if we're thinking about quadratics and cubics, remember quadratics generally make a parabola shape, and cubics generally make this little like squiggle sort of shape. Quadratics are not one-to-one. If we have our horizontal line test, it fails. Cubics, however, are one-to-one. So since cubics are one-to-one, we can solve just using inverse operations. Quadratics, however, we have to use a number line to test our intervals. So if we look at our examples so far, the first one is an example of a quadratic function, and it's asking when is this quadratic function less than 0? Since it's a quadratic, I'm going to start by just solving the related equation. So I'm going to pretend like this inequality sign is an equal sign, and then come back to it when I test my answers on a number line. Right, so now that I've changed it to an equal sign, I'm going to look and see I have two variable occurrences, which means I'm probably either going to have to factor or use quadratic formula in order to solve for x. Hopefully this thing is factorable, so let's see if we can find two numbers that multiply to negative 10x squared and add to negative 3x. Those two numbers would be negative 5x and positive 2x. I'm going to let you continue factoring this, so please pause the video and then restart the video when you've finished factoring. When I factored this one, either using the grouping method or just the more like think about it method, I got x minus 5 times x plus 2 equals 0. Now using the zero product property, I can set each factor equal to 0. And I get, for one of my equations, x equals 5, and for the other equation, x equals negative 2. I have to remember, though, that that's not my final answer. I started off by solving an inequality, and I had to solve the related equation in order to get my two boundary points on the number line. Again, since a quadratic is not one-to-one, we're going to test intervals in between and around the numbers negative 2 and 5. So at this point, remember, we pick numbers in these three intervals. So a number smaller than negative 2 could be negative 3. A number in between negative 2 and 5 could be 0. And a number bigger than 5 could be 6. My job now is to take these three green numbers and plug them into the original inequality to see if they are solutions. So if I plug in the number negative 3 into my original inequality, I would have negative 3 squared minus 3 times negative 3 minus 10, and I'm asking myself if that's less than 0. So from here, I just do order of operations on the left-hand side. I know that negative 3 squared is positive 9. Negative 3 times negative 3 is also positive 9. Minus 10, is that less than 0? 9 plus 9 is 18, minus 10. So I'm asking myself, is 8 less than 0? It is not. So that means that negative 3 is not a solution to the inequality, nor would any number less than negative 2 be a solution. I'm going to go through and test the numbers 0 and 6 as well. If I plug in 0, I have 0 squared minus 3 times 0 minus 10, and I'm asking if that's less than 0. Well, I know that 0 squared is still 0. Negative 3 times 0 is still 0. Minus 10. So really, I'm asking, is negative 10 less than 0? And it is, meaning 0 is a solution along with any other number in between negative 2 and 5. I'm going to go through one more time and check the number 6. So if I plug in 6 is 6 squared minus 3 times 6 minus 10 less than 0. I know that 6 squared is 36. Negative 3 times 6 is negative 18 with our minus 10. 36 minus 18 is 18 minus 10, which gives me 8. And 8 is not less than 0. So 6 is not a solution, nor is any number bigger than 5 a solution. So my answer to this, again, is not just x equals 5 and x equals 2. It's any value in between the numbers negative 2 and 5. So when I write my answer to this inequality, I can write it in two different ways. I can either say that x is greater than negative 2 and less than 5, or I can use interval notation and just say that it goes in between negative 2 and 5, whichever one you prefer. All right, for the next one, I look and I see that I also have a quadratic. So at some point, I'm going to have to test this on a number line. But before I do that, I'm going to just start by solving the related equation. When I do that, I only see that I have one variable occurrence, so I don't have to factor and use the zero product property. I just have to use inverse operations. And I would get x squared equals 3. And then take the square root of both sides and get x equals positive or negative square root of 3. So I'll test these numbers on a number line. I have negative square root of 3 and positive square root of 3. For the numbers in the intervals, since I have a negative and a positive, I know that 0 exists in between both of them. And then I know that the square root of 1 is 1. And the square root of 4 is 2. So this number is somewhere in between 1 and 2. So I'm just going to make it easy on myself and pick a number bigger like 10 and a number smaller like negative 10. You could pick 100 and negative 100 if you wanted to, just to make sure you have numbers on both sides of your number line. So just like I did in the previous problem, I'm going to take these three numbers and plug them into the original inequality to see if they are solutions. If I plug in negative 10, I get negative 10 squared minus 2, is that greater than or equal to 1? I know that negative 10 squared is 100. Minus 2 is 98, and 98 is certainly greater than or equal to 1, meaning that negative 10 is a solution, and anything smaller than the square root of negative 3 is also a solution. If I plug in 0, 0 squared minus 2, is that greater than or equal to 1? I know that 0 squared is just 0, minus 2 is negative 2, and negative 2 is not bigger than 1. And then finally, if I plug in positive 10 squared minus 2 is still going to be 98, and 98 is still greater than 1. So positive 10 is also a solution. This time, when I write my final answer, again, I can write it in inequality notation, and I can say that the x's are less than or equal to the negative square root of 3, or the x's are greater than or equal to positive square root of 3. If I wanted to write this in interval notation, I would say that my solutions go from negative infinity to negative square root of 3, union, and that actually needs to be a hard bracket because we're including that square root of 3, union, positive square root of 3, holy cow, positive square root of 3 to infinity. Moving on to my next one. Again, I see a quadratic here, meaning I would have to solve the related equation and then test my answers on a number line. So my related equation is going to be 2x squared minus x equals 3. At this point, I notice that there are two variable occurrences. So that means at some point I'm probably going to have to factor or use the quadratic formula. I can only do that though if the equation equals 0. This does not equal 0, it equals positive 3. So I'm going to start by subtracting 3 on both sides. Then I would get 2x squared minus x minus 3 equals 0. Now I can continue to factor. I'm looking for two numbers that multiply to negative 6x squared and add to negative x. Those two numbers would have to be negative 3x and positive 2x. Again, I want you to pause your video and factor that with whichever method you prefer, and then restart your video when you're done factoring. When I factored this, I got 2x minus 3 times x plus 1 equals 0. Using the zero product property, I'll set each of my factors equal to 0. And I'll get, if I add 3 on the first one, and then divide by 2, I get x equals 3 over 2, or 1.5. And then for the second equation, I would get x equals negative 1. Again, since it is a quadratic, we do need to test numbers on a number line. So I've got negative 1 and 1.5. If you wanted to pick, you can pick any three numbers you want. If I were you, I would pick 0, then maybe the number 2, and maybe the number negative 2. And you're plugging them in to this original inequality to see if they work. So again, I want you to pause the video and see what happens when you plug in these three numbers, and then I'll show you my work after you pause and try yourself. When I showed my work and I plugged in negative 2, 0, and 2, I got that negative 2 was a solution, 0 was not a solution, and positive 2 was a solution. Remember, when you're plugging in numbers, especially into this first term here, you want to square the number you're plugging in first and then multiply by 2. If you did not get this, go ahead and pause the video again and look through my work to see if you have questions. To write our final answer here, we can write it again in two different ways, inequality or interval. If we wanted to use an interval, we would say that our interval goes from negative infinity to negative 1, union 1.5 to infinity. And if we wanted to use an inequality, we would say that it's all of the x's less than or equal to negative 1, and all of the x's greater than or equal to 1.5. Then finally, for our last example on this first page, we have a cubic. Cubics, remember, are one-to-one, so we do not have to test inequalities on a number line. We just have to solve this using inverse operations. So I'm not even going to make a related equation. I'm just going to start by using inverse operations and adding 5 to both sides. Once I get to this point, I'm going to get rid of the cube by taking the cube root. Now I have x minus 2 is less than the cube root of 8 is 2. I'll add 2 and get x is less than 4. That's my answer as an inequality. If we wanted to write it using interval notation, we would say from negative infinity to positive 4.